Alright. So, we're going to get a fair chunk of it done today. So hopefully on Tuesday the whole trig section will be complete. And move on to the next section. So the first thing I need to do is go back to the cosine rule because I was doing a proof and need to work it out. So let's go back to that. We're on page 51 of your notes. Right, so we're going to look at the proof 6.2. Okay, so way back when I showed you the cosine rule, c squared equals a squared plus b squared, take away 2ab cos c. Okay, let's have a look at a proof of that. Right, so we're just going through the proof of the cosine rule that I started but had too much information on the board, that's why I got confused, and it didn't need to be that much. Right, so we've got our non-right angled triangle. Remember, these sort of rules also works for right angled triangle. Okay, it just simplifies to what we typically know for right angled triangles in terms of cos d equals a over h. Okay, so to show the result, so I'm going to first do the cos of the angle at A. Okay, so the marked angle here, which is the adjacent over hypotenuse. Okay, so we've got the right angle there, so we have x on B. Okay, which means that x is going to be B cos of capital A. Okay, so bringing that up to the top there and set x as subject for that equation. Okay, we call that equation 1 because I'm going to move on to a different setting. I'm going to be recalling that in a moment. Okay, now this is a right angled triangle here as well. Okay, so that means Pythagoras also works. So b squared, which will equal x squared plus h squared. Okay, that is my second equation that again I'm going to come back to. Alright, now that was the left triangle. Over in the right triangle we again have a right angled triangle. I'm not going to do cos of B, however I am going to do the Pythagoras theorem. So the length of the hypotenuse squared is equal to the sum of the square of the two shorter sides. Okay, so the overall length down here is C, because it's opposite the angle C. We've set from the corner to the perpendicular down as the distance of x, and then we set the remaining distance of x take. Thank you, I just realised that. C take away x. Thank you back. Just realised it as you were telling me. Alright, so we C take away x. So the overall length, take away this length here, will give you the remaining length over there. So change the x and C in that bracket. Right, so the next thing I'm going to do is expand this using your algebra rules. So equals h squared plus c squared, take away 2cx plus x squared. Okay, so the middle term needs to be a negative. Multiply the two terms together, double it for that middle term there. And then c and the x, when we square them, will always be positive. Right, so this equals h squared plus x squared. So all I'm doing is bring this up to here. Plus c squared minus 2. So I'm just rearranging that order, because what I have in this bracket here is number 2. So I've got x squared plus h squared. So I'm going to substitute that for b squared. And also I know the value for x, which is b cos a. Alright, so that's equation 3. So equation 1 and equation 2 into equation 3, which will mean a squared. So h squared plus x squared, which is b squared from Pythagoras. So it'll be b squared plus the rest of the equation, c squared minus 2c. And then I've got an expression for x with my cos of a here. So I have a b cos of capital A. Yep, we're pretty much there. A squared equals b squared plus c squared, take away 2bc cos of capital A. Okay, so that's how the formula works. Okay, so you're not required to prove that. However, I like showing you how things work, not just assume that they work, and particularly for extension students, giving you some more practice on algebra, because a lot of that will be based on your extension 1 course with the harder end stuff like this, okay, in terms of rearrangement. Okay, so the length of A, we sum the squares of the two other sides, we take away 2 times the product of the two sides, and we multiply by cos of the angle opposite side we need, and then making sure you're taking the square root, okay? We'll have a look at an example in a moment. Alright, from this we had the other rules, so we needed cos A the subject. Alright, so it's done. So, if I set cos of A subject, okay, to achieve that I'll need to move these two terms on the other side. Before I do that, actually, because the minus sign there, let's move those two over to the other side. We've got a squared, take away b squared, take away c squared, which is negative 2bc cos of capital A. So I'm just moving the b squared and c squared on the other side, changing the sign. Okay, and then I want to get rid of that negative on the right hand side. Okay, so 2bc cos of capital A. So I'm moving it, sort of swapping sides. Okay, so changing the signs. So it'll be b squared plus c squared, take away a squared. So we need to change all these signs when we're moving over to the other side. And then I divide everything by 2bc. So cos of capital A, and b squared plus c squared, take away a squared over 2bc. Alright, so that's the proof. Okay, so again, you don't need to learn the proof, however you need to be able to apply the result. Right, any questions on that? Okay, so let's look at some application. 6.9. Of the two rules, sine rule and the cosine rule. Alright, so let's write them down again. So A over sine capital A is equal to B over sine of capital B, which equals C over sine of capital C. Okay, so the side over the opposite matching angle is sine. If that's the sine rule. Don't forget, if we flip the fraction, that also works. Okay, so if every single fraction gets flipped over, take the consistent equation as well. And we've just gone through the proof of cosine rule when you're finding a side and when you're finding an angle there. Okay, so that was what we have learned. So, you need to be able to determine which equation you need to use when you are given a general non-right angle triangle and you need to find one of the sides or one of the angles. Okay, so the sine rule is when a side and an opposite angle is known. Okay, and we need to find one of the variables, the side or an angle, but we know the opposite angle or side. Okay, depending on what we're finding. Okay. The cosine rule we use when two sides and the included angle are known to find unknown opposite side, or if we know all three sides, we can use the cosine rule to find the angle. Right, let's look at some examples. E. Okay, so we need to find the variable x with the information given to us in the diagram. Okay, so the sine rule is when we know a pair of side and the opposite angle, and we also have another pair of sides and opposite angles with one of them the variable. Okay, so I know x and 58, so I know the variable and the opposite angle is here. However, the other two sides don't tell me what the size of the other two angles are. Okay, so for this particular question, it's not going to be the sine rule. Okay, the cosine rule is when you have two sides and the included angle. Okay, that's like your side angle side and incongruence test, and the variable is on the remaining side. Okay, so you have two sides, included angle, and find the other side. So, we're going to use the cosine rule. Okay, so this triangle is not labelled, it doesn't really need to be. Okay, so as long as you put the right structure into your formula. Alright, so we've got the variable which is x squared. Right, so it's the sum of the squares of the other two sides. So 10 squared plus 12 squared. So this is going to be little c, this is capital C, this can be A, and that can be B. Alright, labelling the diagram to aid us with the question. Take away 2 lots of those two adjacent sides to the angle. 2 lots of the product, sorry. And then we need to times that by cos of C, the cos of 58 degrees. Okay, you have one or two things you can do here. Okay, so you can write this again and take the square root and then write your answer, or you can put this part of it into your calculator and put an approximation and then take the square root. Okay, so in other words, to solve for x, I need to take the square root of both sides. Alright, so in your calculator, let's take the square root of 10 squared plus 12 squared, take away 2 times 10 times 12 times cos of 58. And we need that to the nearest whole number, so the nearest metre. Okay, so we've got two people saying 11. Can the rest of you check it? Did everyone else get 11? Yep, good. Now, in terms of units, of x metres on the diagram, I just need to tell the value for x. Okay, metres is already in the diagram, so it's not necessary to put it in your answer. Okay, you won't get penalised, but you won't if not necessary. Right, F. Okay, so now we're finding the value for theta to the nearest whole number, so in other words, to the nearest degree. Right. So, I've got the angle with the known opposite side, so I've got the variable, the known opposite side, and also in my diagram I have another side and the known opposite angle. Okay, so when I know two sides and opposite angles where one of them is variable, this is where I use the sine rule. Okay, so because I'm finding an angle, I need to put sine on top of the fraction. Okay, if I would find the side, the A's and B's will be on top and the sines will be on bottom. Okay, so always start the top left with my variable. It just makes less messy later on. Alright, so sine of theta over A, which is the opposite side, over 17, which equals sine of the other angle, sine of 43 over the opposite side, which is 12. Right, so you have sine theta. I'm going to bring across and multiply by 17. The 17 times sine 43 over 12 is sine theta. And then theta, so I'm taking it over to the other side of the equation sine. This is where we do our sine inverse. So just like we did when we were finding angles in right angled triangle. And then make sure you have a bracket because you need to take sine inverse of all that. Okay, to the nearest degree. Pardon? 75. Everyone else check that we've got 75? Yep. Alright, so the other thing in the question, you can go from this line here straight to that line if you wish, if you know what you're doing. Okay, I'm just taking it step by step while I'm showing you. Once you're more comfortable, you can take some shorter methods of working. However, while you're learning it, I would like you guys to be writing down the formula each time. That way you're learning it and you'll be able to more easily recall it when we practice further questions. Okay? Now, does everyone understand the difference between using the cosine rule and using the sine rule? Okay? So you've got certain applications for that in terms of what information you give in the diagram. Okay, so you need to be able to distinguish between both of them. Are there any questions before I move on to the next section? So, we're looking at applications of both these rules. So we've just done a revision, how to use the different rules and revise what we did last week. So, applications of both sine and cosine rules are used particularly in bearing style questions. Okay, so we've looked at some simple bearing questions last week or the week before, okay, where we have just right angled. However, now that we have covered the theory on non-right angled triangle, we can now incorporate more difficult bearing questions. Okay, so these style questions that we're going to look at now will be typical of and very common in what you can expect in assessment. Okay, so look at some further examples. Check. Alright, so often they'll give you a couple of sentences with some information, okay, and then from that you need to be able to draw a diagram. Not always will the diagram be provided for you, okay, so that's what I have not included a diagram, so that we can work out how to draw a diagram with information. Right, so when you answer these styles questions, I suggest you read through the whole question first and then go back and start drawing your diagram. Okay, so a ship sails 50 kilometres from port A to port B on a bearing of 63 degrees, then sails 130 kilometres from port B to port C on a bearing of 296 degrees. Okay, so part I, draw a diagram and mark on it all the given information. So let's start again. So a ship sails 50 kilometres from port A to port B on a bearing of 63 degrees. So we've got to remember our bearings. Alright, so 0, 90, 180, 270, back to 360. So technically they're a 3-digit reading, and of course we should always notate which way is true north, which should always be pointed upwards. Okay, so it doesn't have to be an immaculate diagram, okay, however I would think that you would use a straight edge, not just freehand. Okay, so a ship sailed 50 kilometres from port A to port B on a bearing of 63 degrees. So we're considering this as quadrants, okay, we'll be sailing off in some direction in the first quadrant. Okay, so let's make a starting point. On that, put your true north from your reference, and we sail 50 kilometres from port A. So from is where we start and where we go for our bearing, to port B. Okay, doesn't have to be accurate, just in the right general direction, on a bearing of 63 degrees. Alright, so that means from north around to that line, it is 63 degrees there. Then sailed 130 kilometres, so this is B now, so we've got to B. Okay, so again that's north, and that's now port B. Then sailed 130 kilometres from port B to port C on a bearing of 296. Okay, so going back to your original diagram, which general direction are we heading? Northwest, yes. Okay, so 296 is between 270 and 300, so we're going upwards that way. Okay, we're going something like that on a bearing of 296. So that's 50 kilometres there. Is 130 to the point C. 296, so I've got 270 plus the extra 26 degrees to get to 296. Okay, so we don't know where point C is in relation to the starting point. You're just drawing a diagram, just getting the information in there so that we can start answering some questions. Were there any questions about the interpretation of the diagram? No, everyone's sort of following? Alright, so part I, draw the diagram. Okay, so make sure obviously you're leaving a bit of room. Probably need to do a rough sketch first and then do a bigger, tidier sketch. Okay. Alright, double I. Actually, I'll make that my rough sketch and I'll do a nice tidy one. Because I didn't even use the ruler. So, okay, so north. We've gone in some general direction that way. So that's now 63 degrees. This is port A. Okay, there's port B. That's my true north. And then I'm off 26 degrees from the west direction. So that's 50 kilometres, 130, and that's 26 degrees there. Okay, to some point. Let's see. Alright, so we need to show that angle ABC is equal to 53 degrees. Okay, so we need to label the ports. We need to include the sides. Units are not necessary, okay, however when we answer any question involving distance we need to make sure they're included in the answer. We need to show that angle ABC is 53 degrees. Alright, so from the bearing we know that angle there, so we need angle ABC, that whole angle here. Alright, we know this part from here to here, however we need to be able to work out that angle and show that the whole angle is equal to 53 degrees. Suggestion? This one here? Yep. Good. Okay. So this, yep. Excellent. So that's going back to your geometry work. Okay. So this is the right angle here. So this is 27 degrees to make up the 90. And then we have alternate angles. Okay. So this is parallel to that. Okay. So that means this is 27. And then 26 plus 27 is 53 degrees. Okay, so it's asked you to show. That means on my diagram I've shown the numbers necessary that it needs. Okay, and then from that 27 degrees plus 26 degrees, which is equal to 53 degrees. Okay, so you either need to set out a bit of a proof or you label on your diagram and then finish up with showing that you add those two angles together to get the required angle. Alright, find to the nearest kilometre the distance of port A from port support C. From to doesn't really matter. Okay? So in other words, we are now finding the dotted line distance here. Okay? So which of my rules am I going to use? I don't have a right angle triangle in there, so I need to be able to apply the cosine rule or the sine rule. Which one am I going to use and why? Can't use sine. Now remember, this 63 degrees here is from north out. It is not the angle inside the triangle. Okay, I don't actually know for a fact that C is off that bearing. I've just labelled it like that. Okay, for all we know, C could be over here, and that would also change that angle there. So you can't rely on that back there. You need to be able to use other information in the diagram that you know are true to be able to apply the rules. Okay? Sorry? So you've got two sides and the included angle. Yes? So we just found the included angle. We have two sides. When you have two sides and the included angle, it is the cosine rule. Okay? Now, as you work through the question, it is often getting you to a stage where you can answer it. So it's getting you to the stage to find the distance between A and C, but first you need to draw a diagram and you need to decide the size of this angle here. Now, the question before also said shows that angle ABC is 53 degrees. So if you weren't successful in showing that, you know the size of the angle because they've told you, you can still use the cosine rule. Okay? Just because you couldn't show it doesn't mean you can't continue on the question. So we need the cosine rule, c squared, a squared plus b squared, take away 2bc cos of capital A. Ah, yes, sorry. Okay, so let's make the A 50 kilometres and the B 130. Doesn't matter, because you're adding and multiplying, you'll get the same result. So, 50 squared plus 130 squared, take away 2 times 50 times 130 times cos of the angle that was already told to you and you just drew it. Okay, remember when you use the cosine rule, it is a c squared. Okay, so if you just put that part in the calculation, one, you should get some really big number that wouldn't really match the answer. Okay, and two, you will need to do the extra step and take the square root. Okay, so c squared equals that. Take the square root of both sides. Make sure your third goes right along. And show in your examiner that you are taking the square root of the whole expression. Right, so we need c to the nearest kilometre. So? 108. You agree? Nearest kilometre? Right, so once you find that information, I then suggest you label it onto your diagram. Also, while we're on the topic, alright, if you don't want to put your third, because when you try to do the third symbol, you don't get that line straight, the alternate way you can do it is put a bracket to the power of a half. Okay, going back to your indices work, that's an alternate way you can show the square root of something. Much easier to write a bracket and an index. if you don't like doing a little nice long bar for your square root symbol. Okay, but that's your choice. Alright, part 4. Use the cosine rule to find angle ACB. So this time it's actually told you, sometimes they will. And hence find the bearing of port A from port C correct to the nearest degree. ACB. ACB. We need that angle there. Okay, so when we are given 3 sides, we can find any angle inside the triangle. Okay? Because we have just calculated the length of this side, we're already told how long these two are, so we know 3 sides, we can use the cosine rule to find the angle. So, cos of capital C can be A squared plus B squared, so the opposite 2 letters, add the square, take away the lowercase of the angle you're finding and square it, over 2AB. Okay, which is a rearrangement of this formula here, like I've already shown you at earlier this lesson. Alright, so the angle at C is going to be the cos inverse, so I need to take this over to the other side and then put the rest of that information inside the bracket. So A, which is 50 squared plus B squared, so we set B already to 130, take away 108, so squared, so 50 squared plus 30 squared, take away 108 squared, over 2 times 50 times 130. Okay, that needs to be in a bracket because you need to take the cos inverse of that whole angle there. And let's add that to the nearest degree. How many, sorry?
53.
53. We agree? That's the angle. So now we need to write that as the bearing. So hence find the bearing of port A from port C correct to the nearest degree. So let's put that information in the diagram. So 53 degrees there. Okay, we now need to find the bearing of A from C. So what we need to do is put the compass there. And now work out the bearing. How are we going to do this? I hope your diagrams are big enough. Some people are looking quite small. I suggest you do a much bigger diagram, okay, so it's much easier to label. Any ideas?
Find CAB and then alternate
CAB. I wouldn't.
Right, bearing thing, 90, take away 26. Wait, no. Yeah.
Alright, We know this angle here, right? 26 degrees. That means that angle up there is also 26 degrees. And then we start the 53 degrees between B and C and between C and A.
Add 26 and 53 together.
Yeah.
Add it from 90.
Yes. So the angle here is 26 degrees, okay, using your alternate angles for your Z shape. And then from the 90 degrees, so from east, we have an angular measure of 26 degrees plus an extra 53 degrees. So my diagram, because 26 plus 53 is not quite 90, okay, so my diagram is not quite accurate. Okay, so you don't trust your diagram in terms of, yes, my angle should be in the third quadrant of your number plane equivalent. Okay, it's only because I've estimated where C was, but it would be over more. Okay, so bearing. Okay, so from true north, you've got the 90 degree. From true north to get out to east, sorry, plus the 26 for that correct reading there. And then plus the 53, which was the size of the angle from this path to that path. Okay, what do we get? 169. Okay, which would really mean it is going in this direction here from that top section. Okay, so this C would have to be over this way more to go back down to A in that direction there. Okay, so you're not required to accurately plot these points because you're only limited on the information you're given. Okay, but from the diagram and from your procedure of working through the question, you need to mathematically work things out. Okay, and then make sure that you have the correct answers in the end. Right, any questions on that one? Did everyone somewhat follow what's going on? Right, let's make a start on the next question before the bell. Start over here again. Okay, so again, you'll be required to draw a diagram. Okay, so read through the whole question first and then go back and draw your diagram. So two ships leave a port P at the same time. Ship A travels at 12 kilometres per hour on a bearing of 213 degrees. And ship B travels in the southeasterly direction at a speed of 8 kilometres per hour. So draw an illustrated diagram to illustrate the relative positions of the two ships after 3 hours. Right. So let's do a quick draft. So port P. Two ships leave the port at the same time. On a bearing of 213 degrees, ship A travels at 12 kilometres per hour. So remember, this is 90, 180, 270, so off in some direction this way. Okay, at 12 kilometres per hour. And ship B travels in the southeasterly. So you need to know your directions. So that's my true north. Never eat soggy Weet-Bix, clockwise. And travels southeast. Travels in the southeasterly direction. So we're right between south and east. At a speed of 8 kilometres per hour. So this angle here is 45 degrees. The bearing of the first ship was 213, so this is 180. Okay, so we need 90, 200, 210 and another 3. That means this angle here is 33 degrees. Okay, out in those directions. So, the relative positions of the two ships after 3 hours. So now we can actually write down the distance on how far they have travelled. So ship A travels at 12 kilometres per hour. How far away from port P, is it after 3 hours? So 12 times 3. Alright, so that's the first ship, A. So 36. And ship B travelled at a speed of 8 kilometres an hour. So after 3 hours, we're at 24, 8 times 3. 24 kilometres out that way. Right, once you're happy with your sketch, now do a good copy. Okay, remember you're not marked on your accuracy, however you are marked on your general interpretation that you are in the right direction and that you are labelling it correctly as well. Okay. Make sure you label your true north, because that's your reference. This is 45 degrees there. This is 33 degrees there. This is ship A at 36 kilometres from the start, and this is ship B at 24 kilometres from the start. Okay, and that's their relative positions. Okay, nice big space diagram. Probably looking about 1/4 to 1/3 of your page minimum. So we can answer these questions and then you can continue labelling on your diagram. So ship port is P. Right, calculate the distance between ships after 3 hours. Alright, so let's put the... Doesn't have to be dotted. Okay, you can put a straight line there, it's fine. So now we need to calculate that distance. Okay, so in other words, little p. This is little a, this is little b. So what rule am I going to use? Cosine. You have two sides and the included angle known. Okay, and the unknown side is opposite that included angle. Oops. So you need P, which is going to be A squared plus B squared. Take away 2AB because of capital P. Alright, just make a reference to the information from the diagram. There. So P is going to be the square root of 24 squared plus 36 squared. Take away 2 times 24 times 36 times cos of the angle 33 plus 45. Okay, the whole angle that forms here. So this will be it. Calculate the distance after 3 hours. What's your calculator answer?
To the nearest.
Sorry?
What's the nearest?
What do you get in the calculator?
38.8938.
38.8938. Right, always show what you're getting calculated, please. Now, if you go over the question, everything was given in whole numbers. Okay, so the distance, the bearings, everything in whole numbers. Okay, that means your indication of the answer will also be to the nearest whole number. And then you need to state it, the nearest whole number. Okay, the question should probably really state that. However, make sure you're showing your calculator answer. Okay, and then next to it, nearest whole number, like the rest of the question.